Hello students, today we are going to discuss about capillary action. Capillary action means it is the capillarity. What is capillarity? The phenomena of rise or fall of liquid in a capillary tube in comparison to the surroundings is called capillarity. In our daily life, we have seen so many examples for capillary action. You know that we are using blotting paper to absorb extra ink from your notebook. Why we are using blotting paper? You know that in blotting paper, so many capillary tubes are there, and when you put in ink, the capillary tube work there and it sucks the ink. The same way, you know that when you cut the plant stem, the sap, the plant sap, it rises up. That is also one example for capillary action. In our daily life, so many other examples are there. You know that oil rises up in the wick of the kerosene lamp. That is also example for capillary action. Do you know that farmers plow their field only after rains so that the capillaries formed in the upper layer of the soil are broken? Thus, water dropped in the soil is taken up by the plants. On the other hand, we find that when a capillary tube is dipped into the mercury, the level of mercury inside it below the outside level. That is capillary descent. When you dip capillary tube in water, the water rises up. But when you put this capillary tube in mercury, the mercury level sinks down. That is capillary depression or capillary descent. Water rises up, that is called capillary ascent. So, we will say what is meant by capillary action. The phenomena of rise or depression of liquid in the capillary tube is known as capillary action or capillarity. Here we have to derive the expression for capillary ascent. See here, we put a capillary tube in water. We can see here this point A and this point B. Here the meniscus is concave shape, and you have already seen that there is an excess pressure in the concave side. That means at the point A the pressure is more. How much is the pressure difference here? The pressure difference is PA minus PB is equal to 2T by R. R is the radius of the meniscus. T is the surface tension. PA means pressure at the point A and PB means pressure at the point B. That means PA minus 2T by R is equal to PB. That means the pressure at B is less by 2T by R as compared to the pressure at A. But you know that at the point C and D the pressure it is same. Then we know that when we are considering the same point, when we are considering the point at the same level, the pressure should be same. In that sense, pressure at B should be same as the pressure at C. So, to equalize the pressure, what happened? The liquid rises up to a height 2T by R. That means to equalize the pressure at the point B and C, the level of the liquid rises up to this height. That means PA minus 2T by R is equal to PB. This 2T by R pressure at B should be equal to pressure at C. But because of this concave meniscus, pressure at B is less than the pressure at C. To equalize the pressure, the liquid in the tube rises up to a height h. Rho G is equal to 2T by R. So when this liquid rises up to a height of h, then pressure from here to here, it is h rho G. That means 2T by R is equal to h rho G. Then the pressure at B is equal to pressure at C. What explanation I told you, you can read here and see the diagram once more. See, you can see the liquid rises up to a height here, that is h height. Now the pressure at this point and this point, C and this point and this point, it become equal. So already I told you T is the surface tension. Now H rho G is equal to 2T by R. This is our equation number 2. See the notes here. Now see the meniscus of this liquid. It is like a hemisphere and tangent is this one. So this is the angle of contact theta. Then you know that tangent to the sphere and the radius of the sphere, it is perpendicular. Then radius of the capillary tube, that is small r, that is different. Capital R represents the radius of the meniscus. Now this angle is theta, so this is also theta. So from the diagram we can write what is cos theta. What is cos theta? Cos theta is equal to small r by r. Cos theta is equal to small r. Say this one is small r and this one is, so we got it, cos theta is equal to small r by r. Then r is equal to r by cos theta. That you can see here. Now we know the equation H rho G is equal to 2T by R. Here R is capital R, that is the radius of the meniscus. The meniscus is in the form of a hemisphere, so R. So we will put the value here. We will get H rho G is equal to 2T divided by R by cos theta. 2T divided by R by cos theta. That is H rho G is equal to 2T cos theta divided by R. H rho G is equal to 2T cos theta by R. So we got H is equal to 2T cos theta by R rho G. Now you know that theta is the angle of contact. So for a liquid is having concave meniscus, the angle of contact is acute. So cos theta is positive, so H will become positive. So capillary ascent occurs, that is capillary rise. Suppose if it is a convex meniscus liquid, then what happened? Theta is obtuse, though cos theta is negative, so capillary descent occurs. And for pure water, cos theta is equal to cos 0 is equal to 1, then it is 2t by r rho g.